This is Mrs. O'Neill for AP Chemistry Safety Notes. You should have already filled in the first 2 pages of your notes packet during the class activity. Now, can you answer the following as a review for your lab equipment quiz coming in the very near future? So some of them have multiple possibilities. So the possibilities or the answers that I'm going to give you could be different than the ones that you thought of, but that doesn't mean that they're wrong. And of course, some things can be used more than once, like a beaker has multiple uses, so maybe that answer is going to be used more than once. So right now, pause the video, write your answers, then continue playing to see mine. So which lab equipment to use? If you're holding 50 milliliters of boiling water, you might use a beaker or a flask. If you're melting a crystal over a Bunsen burner, you might use a crucible or an evaporating dish. And these are what we call crucible tongs. Why are they called crucible tongs? Because they're specific to hold the crucible's like lid and crucible itself. If we're pouring 50 milliliters of acid from a container to another, you might be using a beaker, definitely a beaker maybe because of the lip on the end, that pouring spout there, and of course a funnel. If we're measuring exactly 43.0 milliliters of water, the only thing you can use is a graduated cylinder. When you're measuring an amount of volume that you need an exact amount, you need to use the graduated cylinder. If you're massing out 120.0 grams of something solid, you would definitely use the balance. Now, when we're using the balance, if we're putting something big on this, like a beaker or a piece of metal, you can just lay it right on there. However, if you're weighing something like sodium chloride here, the salt, and it's a powder, you're going to use that weighing boat first. And we'll go through the procedure on how to use it again to get the mass. How about if we are suspending or using, we're heating something using the burner? Again, you're going to use this ring stand, you're going to use this iron ring, and you want to use the wire gauze on top of it. Now remember, the wire gauze is twofold. One obviously is to keep the beaker on here for stabilization, and the other is, think about your kitchen, right? Here's our burner and it has one flame. Well, that one flame would only heat up the middle if we would just have the beaker straight on that iron ring. However, when you have the beaker on a wire gauze, that wire gauze, this white mesh stuff in the middle here, spreads out to that fire, spreads out the flame and spreads out the heat so that your beaker is heated a little bit more evenly. Okay, so here's the burner again, there's the hose, and there's a striker. If we're removing solids from one container to another, we're going to use a scoopula, very similar to a spoon. Keeping the contents of boiling water from splattering, we sometimes use this watch glass kind of like as a cover. When we're mixing liquids together, you might have said a stirring rod if you're putting 2 things in a beaker and mixing it up, or even a test tube, because we can add 2 things together in a test tube and mix it there. Remember that this is a test tube rack, a test tube holder, and a test tube brush. And those 3 things, again, do different things. The test tube holder just holds a test tube for stabilization. That's a test tube rack. A test tube holder holds the test tube while we're heating it up. And of course, the test tube brush is going to clean it. If we're separating a solid and a liquid, you're going to use a funnel and some filter paper. So do you know what this is and what it would be used for? Hopefully you said thermometer, and it's used to measure the temperature. This is a pipette, kind of like a dropper, and used a lot with micro scale chemistry. And do you know what this is? It is a mortar and pestle used for grinding, taking like a big chunk, let's say, of a salt and grinding it up into little pellets. Okay, so hopefully you know that information and be ready for your quiz. So what is significant about a kitchen in chemistry? I've already talked a couple of things about it, but in your notes, you should have a chart here. So what I want you to do is pause the video and write your thoughts on how can the kitchen be compared to the lab? What are some things that are similar between the kitchen and the lab that we want to be aware of? So hopefully you paused the video, you wrote in a few things. You might have had heat source. I just talked about the burner versus your stove, and it gives us that heat source. How about the sink and water? Remember that the sink is going to provide us with pure H2O that we want. I shouldn't say pure, but the H2O that we need either in our recipes or in our experiments. And of course, ultimately to clean things. The garbage can is to dispose of solids. How about your dishes and your pots and your utensils? Very similar. I said that the scoopula was very similar to your spoon. So if you have something like that as well. So, and the last thing you might not have thought of is, of course, money. So a refrigerator in your house costs money. Well, so does like the balance. So some things are very, very expensive, like the refrigerator and the balance, and some things are not so expensive. Let's say a glass or a plate, and then in the lab would be like a test tube or a beaker. But we want to remember that there is no horse playing around because we don't want anything broken and we want to stay as safe as possible. So your safety contract is very important. You're going to get 2 copies if you didn't get 2 copies already. One should already be signed or getting signed and returned so that you can do those labs. I'm not allowed to let you do a lab unless you and your guardian sign the safety contract that says you will follow those rules during lab to keep everybody safe. The second copy you're going to keep in your notebook as a constant reminder that safety is #1 priority. So here are some rules. Of course, read over that safety contract. There's about 45 to 50 rules. If you have any clarification, again, ask for them. However, here are a few more that are just worth mentioning again and again and again. And again, these are going to be, some are going to be repeated over and over again, but these are the ones that I think you should really know. So in your notes packet, you should pause the video at this point, fill in the blanks. Make sure to read as you write. I'm going to say that all throughout the course. As we're doing this flipped classroom and you're filling in those blanks, you need to read as you write. So hopefully you read that and filled in the blanks. Always goggles, of course. The second bullet there, conduct yourself in a reasonable manner. Again, I don't want anybody hurt. Food and beverages are not allowed because of the fumes and things that can get into your mouth then, and then you'd be digesting it. And knowing the location and use of the safety equipment, we're going to get through towards the end of this video. Some other ones here. We want to remember that almost always liquids are in the sink, solids are in the garbage. We do not have a garbage disposal in the lab like you do at your house. And if you do have broken glassware, it's going to be in a specific box in the back room. Make sure to clean everything before you use it and after you use it. And of course, your hands should be the very last thing that you wash. And that last bullet, very important. Report all accidents and injuries to me immediately, no matter how trivial they may appear. We want to make sure that we get everybody safe. And if you need anything or if I need to replace anything, I do not get mad at accidents or injuries. I make sure that, everybody is just safe. And then if there's any consequences I have to deal with, I deal with it afterwards. #1, again, don't return unused chemicals to their original containers because you don't want to do any cross-contamination. Hot glass and cold glass looks the same. Again, this third bullet, it is easier for you, 23 of you, 20 to 23, however many there are in the class, to check the equipment before you use it than for me to check every little thing. So again, if you see something that is broken or damaged, let me know so I can get you a new one. Make sure to turn on the faucet before putting anything underneath it because it has very, very strong pressure. And if you get a chemical in your skin or your eye, please, please, please wash immediately and have a partner tell me. So now you should pause the video again. You're going to answer those questions 1 through 5 looking at this picture. And one thing I just wanted to show you is this says mirror. So Betty here is doing something with a mirror. So can you pause the video, answer those questions, and then continue playing the video to get the answers? So you should have been able to fill in this chart. I didn't fill in the chart because I'm assuming you can tell what each of those people did that were unsafe, why is it unsafe, and how it can be fixed. So again, I will be looking for that when I check your packet of notes for points. So what should Bob do after the accident? Of course, tell me immediately. What are 3 out of the many things that are not supposed to even be in the lab? Again, I came up with a lot of things. What will happen to Ray and Tim? Of course, they will be asked to sit down. They will get a 0 on their lab report and possibly a write-up. And Carl and Tina, they are doing many things properly. So one new lab equipment that you need to know about is called the volumetric flask. Again, pause the video and write in that definition. The volumetric flask is something I need to go over because it is part of the AP exam. Lots of FRQs have brought up this volumetric flask, and the main use of it is to prepare a solution to a certain molarity. So it's kind of hard to see in this picture, but in this picture you can see that there's a line here and it's 500 milliliters. So that tells me that this flask, once I fill it up to this line, this calibration line, it is going to be exactly 500 milliliters. So it's going to help us make our solutions. So again, pause the video and fill in those notes. How do we make a solution? Well, we're going to put in our desired mass of our solid. We're going to put in water to the neck, and we're going to dissolve, shake, 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 dissolve as much as possible. Then we are going to fill it up to that calibration line as slowly as possible to make sure that we have however many milliliters we want. There's all different sizes. Then we're going to stop it, we're going to invert it, and we're going to shake it very well. I'm going to do that one more time. We're going to stop, we're going to invert, and we're going to shake, shake, shake to get what we need. Okay? So how to prepare solutions. You should also be watching or pause the video and watch this part of the notes. It's only, 2.5 minutes. And again, it helps you understand how to prepare solutions. So we want to remember that anytime we are making a solution, in this case, this example, we're making 1 liter of a solution. So we want to go under that calibration line, add our solute to the solvent, mix, 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 dissolve, 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 make sure it's a full homogeneous mixture, and then fill it up to the line. That's a very important part of this. So there's some AP FRQ practice questions I have for you. So pause the video, see if you can figure out how to calculate the number of grams needed to make 100 milliliters of a 0.5 molar solution of this Na2S2O3. And again, molar means moles per liter. So that might help you understand or get to the units that you want. So, can you come up with a game plan? The game plan would be, oh, and I forgot about this, right? This particular question tells you to pay attention to sig figs. Now the AP exam, there's only 1 point awarded to one of the FRQs, and it is usually the lab-based one. Sometimes they tell you to pay attention to sig figs, and other times they don't, and they just pick one out to give a point to. But what you should have done or thought of is the milliliters that you want, which would be here, 100 milliliters of what you want, to liters. And the reason we have to convert milliliters to liters is because then we're going to be using molarity to change it from liters to moles. And when we have moles using molarity, now we can go to grams. And how are we going to go to grams? Well, we're going to use that molar mass of Na2S2O3. So at this point, if you haven't tried, pause the video and now see if mathematically you can set it up correctly and get an answer. So you should have gotten that and hopefully to 3 sig figs. And here is your points that you would be awarded for. So the second part, or I should say letter F to this, is explain why the 25 milliliter volumetric flask would be a poor choice to use for delivering this required volume. Again, pause the video. Can you come up with an answer? So again, you're talking about the volumetric flask. That's one thing I want to make sure you're understanding. It says the volumetric flask is designed to contain 25 milliliters precisely. So again, it is 1 point for the valid explanation. So you can also say that a volumetric flask has that 1 calibration mark. But remember, always talk about what they're asking about and not the other equipment. All right, so location and use of safety equipment. I'm going to kind of go through this quickly. So here's our safety shower. There's a picture of the room on your notes. I would either draw or write where that safety shower is. Pause the video, and this should make sense. Write something along those lines on how to use it. Number 2 is the Eyewash Station. Again, where is it in the room? Right there. Draw or write it in. And this is how you would use it. Again, as long as you give me on your quiz a somewhat similar explanation, you'll be fine. Fire extinguisher is right there in front of the teacher's desk. How to use it? Again, write something down. The fire blanket. Where is it? This is called a hood, and I keep it right underneath the hood. And this is how you would use it. Last, goggles and aprons. Of course, you know the goggles are here, the aprons are here, and how to use it. Okay, see you in class.